close your eyes, and let's drift northward, to the Arctic Circle, where night skies come alive with dancing ribbons of light, where heaven touches earth in waves of green and violet, where one of nature's most magnificent performances unfolds in silence above the frozen world. Our story begins with a name that captures both poetry and place. The scientific term for the northern lights is aurora borealis, aurora from aurora, the Roman goddess of dawn, and borealis from Boreas, the Greek god of the north wind. The lights were named in 1619 by Italian astronomer Galileo Galilei, who combined these ancient names to describe the mysterious glow he observed in the northern sky. Though Galileo saw the lights from Italy, far south of where they usually appear, he gave them a name that would endure for centuries, a name that speaks of divine beauty and northern mystery. Let yourself relax as we consider what these lights truly are. The aurora borealis is not fire or reflection or earthly light projected onto clouds, as people once believed, but something far more remarkable. The northern lights occur when charged particles from the sun collide with gases in Earth's atmosphere, typically at altitudes between 60 and 200 miles above the surface. These collisions excite the atoms, primarily oxygen and nitrogen, causing them to release energy in the form of visible light. What appears to be a solid curtain of light is actually countless tiny collisions happening simultaneously, each one releasing a photon, together creating the ethereal glow that has mesmerized humanity for thousands of years. Now breathe slowly and picture the most common color of the aurora, that characteristic green that dominates most displays. This green light, which appears at altitudes around 60 to 150 miles, comes from oxygen atoms releasing energy after being struck by solar particles. The specific wavelength of this green light is 557.7 nanometers, a precise color that human eyes are particularly sensitive to, which is why green auroras appear so vivid and bright. It's the same type of oxygen that you breathe, the same element that makes up much of Earth's atmosphere, yet when energized at high altitudes, it glows with this distinctive, otherworldly green that has become the signature color of the northern lights. As you sink deeper into tranquility, consider the rarer colors that sometimes grace the Arctic sky. At higher altitudes, above 150 miles, oxygen produces a deep red or brownish-red glow, though this is less common and often invisible to the naked eye. Nitrogen, the most abundant gas in our atmosphere, creates blue or purplish-red colors when excited by solar particles. The blue comes from nitrogen molecules at lower altitudes, while the purple-red appears at higher altitudes. On exceptional nights, when solar activity is particularly strong, observers report seeing curtains of multiple colors simultaneously, green at the bottom, red at the top, with hints of purple and blue woven throughout, creating a display that resembles a cosmic watercolor painting, fluid and constantly changing, painted across the dome of the sky. Here's something peaceful to contemplate. The northern lights are not actually northern, they occur at both poles. In the southern hemisphere, they're called aurora australis, or southern lights, and they mirror the northern displays almost exactly. The aurora australis appears around Antarctica and the southern regions of Australia, New Zealand, South America, and Africa during their winter months. The lights at both poles are connected, powered by the same solar wind, creating mirror image displays on opposite ends of the Earth. When the northern lights dance over Alaska and Norway, similar lights shimmer above the Antarctic ice, witnessed primarily by penguins, research scientists, and the occasional intrepid traveler. The Earth wears crowns of light at both poles, twin halos of luminescence marking the places where our planet's magnetic field channels the solar wind into the atmosphere. Let your thoughts drift now to the ancient peoples who witnessed these lights long before science explained them. Norse mythology described the aurora as the Bifrost Bridge, or rainbow pathway connecting Earth to Asgard, the realm of the gods. Other Norse legends believed the lights were reflections from the shields and armor of the Valkyries, warrior maidens who chose which fallen soldiers would be taken to Valhalla. The Sami people of northern Scandinavia held deep respect for the lights, believing they were the souls of the departed, and that one should be quiet and respectful when the aurora appeared, never waving, whistling, or singing toward them, for fear of offending these spirits. Across cultures and centuries, the northern lights have inspired awe, reverence, and countless stories, humanity's attempt to explain the inexplicable, to find meaning in the dancing sky. Rest now in this knowledge, floating peacefully beneath imagined auroras, where curtains of light ripple and flow like silk in a gentle breeze, where the boundary between Earth and cosmos becomes visible, luminous, and infinitely beautiful. Breathe slowly and let yourself drift deeper into the Arctic night, as we explore the cosmic origins of these celestial lights. Let us journey now to the source of the aurora, our sun, that brilliant star 93 million miles away. The northern lights begin not on Earth but in the violent, roiling atmosphere of the sun, where nuclear fusion generates temperatures of millions of degrees. From the sun's outer atmosphere, called the corona, streams a constant flow of charged particles, mostly electrons and protons, traveling outward in all directions at speeds of about 1 million miles per hour. This river of particles is called the solar wind, and it bathes the entire solar system in a continuous stream of energy and matter. The solar wind takes about 2 to 3 days to travel from the sun to Earth, carrying with it the seeds of aurora, invisible travelers crossing the vast darkness of space. As you relax even deeper, consider what happens when this solar wind encounters Earth. Our planet is protected by an invisible shield, the magnetosphere, a magnetic field generated by the churning molten iron in Earth's core. This magnetosphere extends tens of thousands of miles into space, deflecting most of the solar wind around our planet like water flowing around a rock in a stream. Without this protective magnetic field, the solar wind would strip away our atmosphere, making Earth uninhabitable, much as has happened to Mars, which lost most of its magnetic field billions of years ago. But Earth's magnetosphere does more than just protect us, it also channels some solar particles toward the poles, funneling them down magnetic field lines toward the Arctic and Antarctic regions, where they create the aurora. Let your thoughts drift to the shape of the aurora zone, the region where northern lights most commonly appear. The aurora doesn't occur directly at the North Pole but in an oval-shaped band called the auroral oval, centered on the magnetic North Pole rather than the geographic North Pole. This oval typically sits at latitudes between 65 and 75 degrees north, encompassing northern Alaska, Canada, Greenland, Iceland, and northern Scandinavia. The auroral oval isn't fixed but expands and contracts depending on solar activity. During periods of intense solar storms, the oval can expand dramatically, bringing the northern lights to much lower latitudes, occasionally as far south as the northern United States or even, on rare occasions, to places like Texas or the Mediterranean. Now breathe gently and picture the aurora's movement and behavior. The northern lights are not static but constantly in motion, shifting, pulsing, and flowing across the sky. This movement reflects the dynamic nature of Earth's magnetosphere responding to changes in the solar wind. When the solar wind strengthens or shifts direction, the aurora responds almost immediately, brightening, dimming, or changing shape within seconds. The lights can appear as diffuse glows, as distinct rays shooting upward, as flowing curtains that ripple like fabric in wind, or as coronas that seem to radiate from directly overhead. Some displays last only minutes, others persist for hours, their forms constantly evolving, never the same from one moment to the next. As you sink into deeper tranquility, consider the intensity scale used to measure auroral activity. Scientists use the KP index, which ranges from 0 to 9, to indicate the strength of geomagnetic storms and the likelihood of seeing aurora. A KP of 0 to 2 means quiet conditions with aurora visible only from the far north. KP 3 to 4 indicates active conditions with visible displays throughout the auroral zone. KP 5 to 6 represents minor to moderate geomagnetic storms, pushing the aurora to lower latitudes. KP 7 to 9 indicates major geomagnetic storms, with the aurora potentially visible from much farther south. These are the events that bring northern lights to viewers who rarely see them, creating memories that last a lifetime. Weather services and aurora forecast websites now provide these predictions, allowing modern travelers to plan their aurora hunting expeditions, though the lights, like all wild things, remain ultimately unpredictable. Here's something both fascinating and peaceful: the aurora makes sound, though you usually cannot hear it. For centuries, indigenous peoples and northern residents reported hearing crackling, whooshing, or clapping sounds accompanying bright auroral displays, but scientists dismissed these reports because the aurora occurs too high in the atmosphere for sound to travel to the ground. However, recent research has confirmed that under certain conditions, the aurora does produce audible sounds, likely created by electrical discharges in the lower atmosphere responding to the charged particle environment created by the aurora overhead. These sounds occur at ground level, close enough to hear soft, subtle noises that add an auditory dimension to the visual spectacle, making the experience even more otherworldly. Rest peacefully now, imagining yourself standing in the Arctic night, watching curtains of green light dance overhead, perhaps hearing the faint whisper of their passage, knowing you're witnessing a connection between Earth and Sun, between magnetic field and solar wind, between our planet and the star that gives us life. Let yourself drift even deeper into the peaceful night, as we explore the patterns, timing, and rhythms of these ethereal lights. Drift with me now to understand when the northern lights appear most frequently. Aurora displays follow an 11-year cycle that mirrors the sun's activity cycle. During solar maximum, the peak of the sun's 11-year cycle, sunspots, solar flares, and coronal mass ejections occur more frequently, sending stronger bursts of charged particles toward Earth and creating more frequent and intense auroral displays. During solar minimum, the sun is quieter, and aurora sightings become less common, though they never disappear entirely. The most recent solar maximum occurred in 2014, and the next is expected around 2025. Meaning we're currently in a period of increasing solar activity, with more spectacular aurora displays becoming more frequent as we approach the peak. As you breathe slowly and peacefully, consider the best time of year to see the northern lights. While the aurora occurs year-round, it's only visible when the sky is dark enough to see it. In the far north, summer brings the midnight sun, weeks or months of continuous daylight, making it impossible to see the aurora even though it's still happening high in the atmosphere. The best aurora viewing season runs from late August through April, with the darkest months of winter, December and January, offering the longest viewing windows. However, September and March often provide the best combination of dark skies and active displays, as these equinox months seem to produce more frequent geomagnetic storms. The aurora cares nothing for our seasons or schedules, but the darkness required to see it imposes a rhythm on when we can witness its beauty. Let your thoughts drift to the best time of night for aurora viewing. The northern lights can appear at any time when the sky is dark, but statistically, the most active period is between 10 p.m. and 2 a.m. local time. This is when Earth's night side faces most directly into the solar wind flowing past our planet. The hours around midnight are often called aurora prime time, when the magnetosphere is under the most stress and most likely to respond to solar wind changes with brilliant displays. Yet the aurora is gloriously unpredictable. Sometimes the best displays occur at dusk or dawn, sometimes they persist all night long, and sometimes they appear briefly and vanish, like a shy performance meant for only a few lucky observers. Now breathe gently and picture the different forms the aurora takes. Scientists classify auroral displays into several types. Diffuse aurora appears as a faint, steady glow without distinct structure, like a distant fog of light. Discrete aurora forms visible rays, arcs, or curtains with clear edges and structure. Pulsating aurora brightens and dims rhythmically, as if the sky is breathing. Corona aurora appears when you're standing directly beneath a display, with rays seeming to radiate from a point directly overhead, creating the illusion of looking up through a tunnel of light into space. Some of the most memorable displays combine all these forms, with pulsating glows giving way to arcs that suddenly brighten into flowing curtains, which then reorganize into rays shooting upward before the entire display dims and begins its transformation anew. As you sink into deeper tranquility, consider that the northern lights are visible from space, but they look quite different. Astronauts aboard the International Space Station orbit at an altitude of about 250 miles, placing them above most auroral displays. From their vantage point, the aurora appears as glowing ribbons and spirals draped across Earth's curved surface, following the magnetic field lines that channel the solar particles. The ISS frequently passes through the auroral oval, sometimes even flying through the aurora itself. Astronauts report seeing the green glow beneath them, spreading across thousands of miles of Earth's surface, a perspective no ground-based observer can achieve, a view of the aurora as a planetary phenomenon rather than a celestial one, Earth wearing a luminous crown visible from the darkness of space. Here's something both scientific and peaceful: the total energy released by a major auroral display is enormous, comparable to a large earthquake or the energy consumption of a major city for an entire year. Yet this energy is spread across thousands of square miles and released over hours, making it gentle from any individual perspective. The aurora is powerful in aggregate but delicate in detail, each photon the result of a single collision between a solar particle and an atmospheric atom. You could stand beneath the brightest aurora, feeling the cold Arctic air on your face, and experience nothing but the visual spectacle: no heat, no radiation, no danger, just pure light dancing overhead, a demonstration of cosmic forces made gentle through distance and distribution. Rest now beneath these flowing curtains of light, knowing they dance to rhythms both predictable and wild, following solar cycles measured in years and magnetic fluctuations measured in seconds, part of an eternal dance between our star and our planet. Breathe softly and let yourself float through the historical tapestry of human encounters with the aurora, where science and story intertwine. Let us journey now to the historical records of the Northern Lights, which stretch back thousands of years. The earliest confirmed written record of the aurora comes from ancient Babylon, where observers recorded what they described as a red glow in the night sky around 567 BCE. Ancient Chinese records from several centuries BCE describe the aurora as radiant vapors or dragons in the sky, documenting displays that must have been particularly strong to be visible so far south. Ancient Greek and Roman texts occasionally mention mysterious lights in the northern sky, though these southern civilizations rarely witnessed the phenomenon. These ancient records not only document human wonder but also provide scientists with data about solar activity going back millennia, helping us understand the long-term patterns of our sun's behavior. As you relax even deeper, consider the aurora's role in indigenous Arctic cultures. The Inuit peoples of North America have lived beneath the aurora for thousands of years, developing rich traditions and beliefs about the lights. Some Inuit groups believe the aurora was spirits of their ancestors playing a game with a walrus skull used as a ball. Others saw them as spirits of animals, particularly beluga whales, seals, and salmon, dancing in the sky. In Inuit tradition, if you whistled at the aurora, the lights would come closer, but this was considered dangerous, as the spirits might snatch you away. These weren't simply superstitions but sophisticated ways of incorporating a mysterious natural phenomenon into a coherent worldview, giving meaning to the dancing lights that appeared without warning in the long Arctic night. Let your thoughts drift to a historical event that changed our understanding of the aurora forever. On September 1, 1859, British astronomer Richard Carrington was observing sunspots when he witnessed a massive solar flare, the first ever recorded observation of such an event. Within 17 hours, Earth was struck by one of the most powerful geomagnetic storms in recorded history, now known as the Carrington event. The resulting aurora was so bright that people across Europe and North America could read newspapers by its light at midnight. The lights were visible as far south as Cuba, Hawaii, and Colombia, places where aurora had never been seen before and haven't been seen since. Telegraph systems worldwide failed, with operators reporting electrical shocks and equipment catching fire. This event demonstrated conclusively that the aurora was connected to solar activity, helping launch the modern era of space weather science. Now breathe gently and picture the early scientific attempts to understand the aurora. In the 1770s, British scientist Henry Cavendish calculated the altitude of the aurora through triangulation, determining that the lights occurred at least 60 miles up, far higher than any clouds. In the 1890s, Norwegian physicist Christian Birkeland conducted groundbreaking experiments, creating a miniature aurora in his laboratory by bombarding a magnetized sphere with electrons, demonstrating that charged particles interacting with a magnetic field could indeed produce the northern lights. Birkeland's work was initially controversial, but his theory, that the aurora was caused by electrons from the sun interacting with Earth's magnetic field, was eventually proven correct, earning him recognition as one of the fathers of space physics. As you sink into deeper tranquility, consider that the aurora played a role in World War II. Allied forces planning operations in northern regions had to account for the northern lights, which could interfere with radio communications at crucial moments. The unpredictable nature of auroral displays sometimes disrupted military communications when coordination was most critical. Conversely, bright aurora occasionally provided enough light for nighttime operations in regions that would otherwise be in complete darkness during winter months. The northern lights, indifferent to human conflict, continued their ancient dance above battlefields and peaceful settlements alike, a reminder that cosmic forces pay no attention to earthly concerns. Here's something peaceful to contemplate. In Finland, there's a belief that when you see the northern lights, the aurora is caused by the firefox, a mythical creature running across the snow, its tail brushing the mountains and sending sparks into the sky. The Finnish word for the northern lights is revanchelit, which literally means fox fires. This beautiful legend connects the aurora to the natural world in a way that feels both whimsical and reverent, transforming the cosmic phenomenon into something almost approachable, as if the lights were created by a creature of Earth rather than by forces from the sun. It's a gentler interpretation than some others, inviting wonder rather than fear, celebrating the aurora as a gift to be appreciated rather than a mystery to be avoided. Rest peacefully now, knowing that for thousands of years, humans have looked up at these lights with wonder, each culture finding their own meaning, each generation adding to our understanding, until we arrived at our current knowledge, a blend of science and story, of measurement and marvel. Let yourself drift deeper still, as we explore the places where the aurora appears most brilliantly and the modern quest to witness its beauty. Drift with me now to Tromsø, Norway, a city often called the capital of the Arctic and one of the premier aurora viewing destinations in the world. Located at 69 degrees north latitude, well within the auroral oval, Tromsø offers excellent chances to see the northern lights from late September through late March. What makes Tromsø particularly special is its accessibility. This is a modern city of 75,000 people with an airport, hotels, and infrastructure, yet it sits directly beneath some of the most active aurora zones. The Gulf Stream keeps the harbor ice-free year-round despite the Arctic latitude, and the surrounding mountains and fjords create dramatic landscapes over which the aurora dances. On clear winter nights, residents simply step outside their homes to witness displays that travelers journey thousands of miles to see. As you breathe slowly and peacefully, consider Fairbanks, Alaska, another renowned aurora destination. Positioned at 65 degrees north latitude, Fairbanks sits just south of the Arctic Circle but directly beneath the auroral oval. The city experiences some of the clearest, coldest winter weather in the inhabited world, with temperatures sometimes dropping below -40 degrees Fahrenheit. These frigid conditions create exceptionally dry air with minimal cloud cover, offering crystal-clear views of the aurora on more than 200 nights per year during the viewing season. Local tour operators lead visitors away from the city lights to viewing locations where the aurora reflects off snow-covered landscapes, doubling the visual impact. The Chena Hot Springs Resort near Fairbanks offers the surreal experience of watching the northern lights while soaking in naturally heated pools, the steam rising into the frozen air as green curtains ripple overhead. Let your thoughts drift to Iceland, a volcanic island nation that has become synonymous with aurora tourism. Iceland's position just south of the Arctic Circle, combined with its dramatic landscapes of waterfalls, geysers, glaciers, and black sand beaches, creates ideal conditions for aurora photography and viewing. From late August through April, the lights appear regularly over this island, often dancing above steaming hot springs or glacial lagoons filled with floating icebergs. Ingvellir National Park, where the North American and Eurasian tectonic plates are pulling apart, offers the unique experience of watching the aurora above a rift valley where Earth's crust is literally tearing itself apart, cosmic forces observed above geological forces, layers of Earth's dynamism visible simultaneously. Now breathe gently and picture the lengths some people go to pursue the aurora. Aurora chasers, dedicated enthusiasts who travel repeatedly to witness the lights, plan trips around solar forecasts, moon phases, and weather patterns. They study maps of light pollution, consult real-time magnetometer data, and sometimes drive hundreds of miles in a single night to escape clouds or find clearer skies. Some have witnessed hundreds of displays, yet they return again and again, because no two auroras are identical. The combination of unpredictability and transcendent beauty creates a gentle obsession, a pilgrimage repeated season after season. These aurora chasers understand that witnessing the lights requires patience, flexibility, and a willingness to embrace uncertainty, qualities that make the eventual success even more rewarding. As you sink into deeper tranquility, consider the aurora borealis as it appears in indigenous Scandinavian Sami culture. The Sami, who have inhabited the Arctic regions of Norway, Sweden, Finland, and Russia for thousands of years, traditionally viewed the aurora with respectful caution. They believed the lights possessed power and that making noise, singing, or whistling while the aurora appeared could anger the spirits and bring misfortune. Children were warned to be quiet and well-behaved when the lights danced overhead. This reverence reflects a deep understanding that the aurora represents forces beyond human control, not supernatural in the sense we understand it, but natural forces so vast and powerful that they demanded respect. The Sami relationship with the aurora wasn't based on fear but on recognition of its power and otherness. Here's something both practical and peaceful. Modern technology has made aurora forecasting surprisingly accurate in the short term. Space weather prediction centers monitor the sun constantly through satellites positioned between Earth and the sun, particularly the Discover satellite at the L1 Lagrange point, about 1 million miles from Earth. When a coronal mass ejection leaves the sun, these satellites can detect it and predict, with about 30 to 45 minutes notice, when the solar particles will reach Earth and how strong the resulting geomagnetic storm might be. Numerous websites and smartphone apps now provide aurora alerts, notifying users when displays are likely. This technology has democratized aurora viewing, allowing people to know when to venture outside, when to stay up late, when to make the drive away from city lights, transforming aurora watching from pure chance to informed patience. Rest now beneath imagined northern skies, knowing that people around the world are planning journeys to witness these lights, that clear nights in the Arctic are filled with watchers looking up in hope, that the aurora connects us across cultures and centuries through shared wonder. Breathe softly and let yourself float through the artistic and photographic dimensions of the aurora, where human creativity meets natural wonder. Let us drift now to the challenge and beauty of photographing the northern lights. Aurora photography requires patience, technical skill, and the right equipment. The human eye perceives aurora differently than a camera. Our eyes see the aurora in real time but with less color intensity and detail than long-exposure photographs reveal. A camera with its shutter open for 5 to 15 seconds can accumulate light, capturing colors and structures invisible to the naked eye, revealing purples and reds that might appear only as faint glows to an observer. This means that photographs, while stunning, don't always reflect the direct viewing experience. Yet both are valid. The photograph captures what is objectively there, while the eye captures the immediate, living dance of light and motion. Modern photographers often create time-lapse videos that compress hours of aurora into minutes, showing the full drama of a display's evolution in a way no single moment could capture. As you relax even deeper, consider that the aurora has inspired artists for generations, though capturing its ephemeral beauty has always posed challenges. Early Arctic explorers attempted to sketch the lights, but their drawings, constrained by the limitations of pen and paper, could only hint at the aurora's fluidity and color. In the 19th and early 20th centuries, painters began incorporating the northern lights into landscape paintings, though many had never witnessed them personally and relied on descriptions from travelers. The aurora appears in the works of famous painters like Frederick Edwin Church, whose 1865 painting Aurora Borealis depicted a dramatic display over icebergs and sailing ships, helping introduce the phenomenon to audiences who would never travel to Arctic regions. Today, photographers, filmmakers, and digital artists continue this tradition, each generation finding new ways to capture and share the aurora's transient beauty. Let your thoughts drift to the aurora's appearance in literature and poetry. Writers have struggled with the same challenge as visual artists: how to describe in words something so visual, so dynamic, so otherworldly. Scottish poet Robert Service, who lived in the Yukon during the Klondike Gold Rush, wrote of the blaze of crimson fire and streamers pale and white in his northern poems. American naturalist John Muir described the aurora as a glorious outburst of silvery light, sweeping across the sky in quick, quivering currents. French novelist Jules Verne included the aurora in several works, describing it as vast sheaves of electric light and immense cupolas of luminous vapor. These literary attempts to capture the aurora remind us that some experiences resist easy description, that witnessing the aurora is fundamentally different from reading about it or seeing photographs. It must be experienced directly: the cold air on your face, the darkness surrounding you, the lights dancing overhead in real time. Now breathe gently and picture the aurora's influence on music. Contemporary composers have created pieces inspired by the northern lights, attempting to translate visual experience into sound. Norwegian composer Ola Gilo wrote Northern Lights, a choral work that captures the aurora's ethereal quality through sustained, slowly shifting harmonies. Icelandic musicians, particularly those in ambient and post-rock genres, frequently cite the aurora as inspiration, creating soundscapes that mirror the light's gradual transformations and sudden bursts of intensity. Some have even attempted to sonify actual aurora data, converting measurements of electromagnetic fluctuations into audible tones, creating a kind of aurora music based on the physics of the phenomenon itself. While the aurora itself is silent to human ears, these musical interpretations offer another way to experience and share its beauty. As you sink into deeper tranquility, consider the spiritual and meditative aspects of aurora viewing. Many people who witness the northern lights describe the experience as transformative, even spiritual. There's something about standing in the darkness, looking up at a phenomenon so vast and so beautiful, that puts daily concerns into perspective. The aurora invites stillness, patience, and presence. You cannot force it to appear, cannot control its behavior, can only accept what it offers. Many aurora viewers report feeling a sense of connection to something larger than themselves, whether they interpret that as nature, the cosmos, or the divine. The experience of watching the aurora can be profoundly meditative, requiring you to be fully present in the moment, in the cold, in the dark, witnessing beauty that exists whether or not anyone is there to see it. Here's something peaceful to contemplate: aurora viewing lodges and hotels in the far north often feature glass-roofed rooms or domes specifically designed for aurora watching. These structures allow guests to lie in warm beds while watching the sky, combining comfort with the dramatic experience of witnessing the lights. Some lodges in Finnish Lapland offer glass igloos heated to room temperature, with transparent roofs providing unobstructed views of the sky. The juxtaposition, warmth inside, Arctic cold outside, the aurora dancing overhead, creates a unique experience, making the lights accessible to those who couldn't withstand hours in the freezing darkness. These accommodations recognize that aurora viewing is an experience worth crafting infrastructure around, that people will travel thousands of miles and pay premium prices for the privilege of watching these lights in comfort. Rest peacefully now, imagining artists and photographers, writers and musicians, all attempting to capture the aurora's essence, knowing that the lights inspire creativity across all human endeavors, that they bridge science and art, fact and feeling, observation and imagination. Let yourself drift deeper into the scientific mysteries and remarkable discoveries that continue to unfold around the aurora. Drift with me now to understand substorms, the dynamic events that drive auroral displays. A magnetospheric substorm is a brief disturbance in Earth's magnetosphere, typically lasting 1 to 3 hours, during which energy stored in the magnetotail, the part of Earth's magnetic field stretched out by the solar wind, is suddenly released. This release sends charged particles cascading into the atmosphere, creating the brightest, most active aurora displays. During a substorm, a quiet aurora can suddenly explode into vivid, rapidly moving curtains and rays, brightening dramatically within seconds. These substorms can occur multiple times in a single night, each one creating a surge of auroral activity before the display calms again. Scientists are still working to fully understand what triggers substorms. They know the general conditions that make them likely, but predicting the exact moment of onset remains challenging, keeping an element of mystery in even our most advanced aurora science. As you breathe slowly and peacefully, consider Steve, a recently identified atmospheric phenomenon whose full name is strong thermal emission velocity enhancement. Steve appears as a narrow ribbon of purplish-white light stretching east-west across the sky, often accompanied by vertical green picket fence structures. For years, aurora photographers captured images of Steve, calling it a proton arc, but in 2016, citizen scientists working with professional researchers discovered that Steve is not actually an aurora at all. It occurs at lower latitudes, involves different physical processes, and appears during different magnetic conditions. Steve represents a completely new atmospheric optical phenomenon, discovered not by professional researchers but by amateur aurora watchers who noticed something unusual and brought it to scientists' attention. This discovery demonstrates that even in our age of satellite monitoring and sophisticated instruments, careful observation by dedicated amateurs can reveal phenomena science has overlooked. Let your thoughts drift to the connection between aurora and the Van Allen radiation belts, two donut-shaped zones of charged particles trapped by Earth's magnetic field. The inner belt extends from about 400 to 3,700 miles above Earth's surface, while the outer belt reaches from about 8,000 to 36,000 miles up. These belts, discovered in 1958 by American physicist James Van Allen using data from the Explorer 1 satellite, represent the magnetosphere's particle storage system. During geomagnetic storms, particles from these belts can be dumped into the atmosphere, contributing to auroral displays. The Van Allen belts also pose radiation hazards to satellites and astronauts passing through them. The same process that creates beautiful aurora on Earth creates dangerous radiation zones in space, a reminder that the aurora is part of a complex system with both benign and hazardous aspects. Now breathe gently and picture auroral arcs, one of the most common and beautiful auroral forms. These arcs can stretch for hundreds or even thousands of miles across the sky, following Earth's magnetic field lines. A single arc might extend from eastern Alaska across northern Canada to Greenland, a curtain of light spanning an entire continent. From any single viewing location, you see only a portion of this vast structure. The arc continues beyond the horizon in both directions. Multiple arcs can appear stacked at different altitudes and latitudes, creating layers of light at varying distances. Sometimes these arcs remain stable for hours, hanging motionless in the sky like frozen waves. Other times they pulse, ripple, or suddenly transform into more dynamic forms, demonstrating that even simple-looking structures can harbor complex, evolving behavior. As you sink into deeper tranquility, consider the aurora's role in modern research on space weather. Just as meteorologists study Earth's weather to predict storms and protect people from hazards, space weather scientists study the Sun and Earth's magnetosphere to predict geomagnetic storms and their effects. Strong geomagnetic storms can disrupt power grids, damage satellites, interfere with GPS navigation, and pose radiation risks to airline crews on polar routes. The aurora serves as a visible indicator of space weather activity. When the lights are particularly active, scientists know that Earth's magnetosphere is being strongly affected by solar activity. Research stations across the Arctic monitor the aurora constantly, feeding data into models that help predict and mitigate space weather impacts, transforming the northern lights from objects of pure wonder into practical indicators of our electromagnetic environment. Here's something both fascinating and peaceful. Different planets in our solar system have their own auroras. Jupiter and Saturn, with their strong magnetic fields, both have spectacular auroral displays far more powerful than Earth's. Jupiter's aurora are permanent features at its poles, powered not just by the solar wind but also by volcanic activity on its moon Io, which pumps ions into Jupiter's magnetosphere. Saturn's aurora respond to changes in the solar wind, much like Earth's. Even planets without magnetic fields can have aurora-like phenomena. Mars and Venus have localized aurora caused by interactions between the solar wind and surface magnetic anomalies or the planet's atmospheres. Uranus and Neptune, the ice giants, also have aurora, though their magnetic fields are tilted and offset from their rotation axes, creating unusually complex auroral patterns. Throughout the solar system, wherever magnetic fields and charged particles interact, light dances in the darkness. Rest peacefully now, knowing that the aurora is part of a much larger system, that the lights you see are windows into invisible forces, that every display teaches us something new about our planet, our star, and the space between them. Breathe softly and let yourself float through the final mysteries and personal dimensions of the northern lights, bringing our journey to its gentle conclusion. Drift with me now to consider the personal nature of aurora experiences. No two people see the aurora exactly the same way, even when standing side by side. Your eyes may be more sensitive to green, while your companion sees more purple. Your mind might perceive rapid movement where someone else sees gentle flowing. Memory and emotion color the experience. The aurora you see on your first night under Arctic skies will be remembered differently than displays you witness after seeing dozens. Some people cry when they first see the northern lights, overwhelmed by beauty they've only imagined. Others feel quiet peace, a sense of connection to something vast and timeless. The aurora offers each observer a unique gift, a personal moment of wonder that, despite being a physical phenomenon governed by knowable laws, feels intimate and meaningful in ways that transcend scientific explanation. As you relax even deeper, consider how climate change is affecting aurora viewing opportunities. As Arctic regions warm, cloud patterns are shifting, potentially altering the frequency of clear viewing nights. Some traditionally reliable viewing locations now experience more variable weather. Paradoxically, as the Arctic becomes more accessible due to reduced sea ice and improved infrastructure, the number of clear nights suitable for viewing may decrease in some areas while increasing in others. Additionally, scientists are studying whether changes in Earth's upper atmosphere due to increased greenhouse gases might affect the altitude or intensity of auroral displays themselves. The aurora, ancient and seemingly unchanging, exists within an atmosphere that is rapidly transforming, connecting this celestial phenomenon to very earthly concerns about how human activities are reshaping our planet's systems. Let your thoughts drift to the simple practical wisdom of aurora viewing. Those who successfully see the northern lights often follow certain guidelines. Stay at least 3 nights to increase your odds, as clear weather is never guaranteed. Choose locations far from city lights, where light pollution won't wash out fainter displays. Dress far more warmly than you think necessary. You'll be standing still in Arctic temperatures, and what feels tolerable for 5 minutes becomes uncomfortably cold after an hour. Bring patience and flexibility, understanding that the aurora operates on its own schedule, not yours. Let your eyes adjust to darkness for at least 20 minutes before expecting to see faint aurora. And perhaps most importantly, put down your camera occasionally and simply watch. Photographs are wonderful souvenirs, but the direct experience of watching the aurora with your own eyes, in the moment, creates memories that no image can replace. Now breathe gently and picture the future of aurora research and tourism. Scientists are developing more sophisticated models to predict not just when aurora will occur but what forms they'll take and how bright they'll be. New satellite missions will provide better real-time monitoring of solar wind conditions. Ground-based auroral research stations are being upgraded with advanced cameras and sensors that can capture phenomena invisible to human eyes. Meanwhile, aurora tourism continues to grow, with destinations throughout the Arctic Circle developing infrastructure to accommodate visitors seeking this experience. Virtual reality aurora experiences are being created for those who cannot travel north, though these can only approximate the real thing. The aurora is simultaneously becoming more accessible through technology and tourism, and more appreciated as a rare, precious experience worth preserving and protecting. As you sink into the deepest tranquility, consider that the aurora connects us to cycles far larger than human timescales. The 11-year solar cycle that drives auroral frequency has operated for billions of years, long before humans existed to witness it. The magnetic field that creates the aurora has protected Earth for most of its history, making life possible. The solar wind that powers the lights is part of our sun's life cycle, which will continue for billions of years after we're gone. When you watch the aurora, you're witnessing a process that predates humanity and will continue long after our species has either evolved into something else or disappeared entirely. This perspective is both humbling and comforting. We are temporary, but the dance between star and planet endures. Here's a final, peaceful thought to carry you into dreams. The aurora borealis reminds us that the universe is both comprehensible and mysterious, both explained and unexplainable. We understand the physics, charged particles, magnetic fields, atmospheric chemistry. We can predict when displays will occur, photograph their structures, measure their energy. Yet understanding doesn't diminish wonder. Knowing why the aurora exists doesn't make it less beautiful when you stand beneath glowing curtains of green and violet light, the cold air sharp in your lungs, the cosmos made visible overhead. The aurora teaches us that science and poetry need not conflict, that explanation and wonder can coexist, that understanding the mechanism of beauty doesn't destroy its magic but rather deepens our appreciation for a universe capable of creating such phenomena through the elegant interplay of natural forces. Rest now in complete peace, wrapped in the memory of dancing lights you've never seen but can imagine, knowing that above the Arctic Circle, even as you sleep, the aurora may be illuminating the darkness, witnessed or unwitnessed, dancing its eternal dance, connecting Earth to sun, magnetosphere to solar wind, science to wonder, and all who see it to something vast, beautiful, and mysteriously meaningful. The northern lights continue their patient performance, waiting for the next observer to look up in awe, reminding us that our planet is part of a dynamic, interconnected cosmic system, and that beauty and wonder persist whether or not anyone is present to witness them. Sleep peacefully now, beneath imagined auroras of green and violet, knowing you are part of the same universe that creates these lights, that the same atoms that glow in the aurora exist in you, that you are connected to the cosmos through forces both visible and invisible, through beauty both explained and eternal. Good night, aurora watcher. Good night, northern traveler. Rest well beneath the dancing lights that shimmer across the roof of the world, painting the darkness with color and motion, reminding us that Earth is not separate from space but connected to it through invisible threads of magnetism and light. Rest. Peace. Sleep. Tonight, as you begin to rest, imagine the world growing quieter. The sky stretches wide above you, dark and patient, as though it has been waiting all day just for this moment. Far above the sleeping Earth, something ancient is already on the move. Long before anyone ever gave them a name, the northern lights were dancing silently across polar skies. Early civilizations watched them with wonder, unsure whether they were spirits, messages, or fires burning in the heavens. Much later, scientists would give them a softer name, auroraborealis, named after Aurora, the Roman goddess of dawn, and Boreas, the god of the north. Even the name itself feels like poetry, whispered rather than spoken. The story of the northern lights doesn't begin on Earth at all. It begins 93 million miles away, on the surface of the Sun. The Sun is constantly releasing tiny charged particles into space, like a slow, endless breath. This stream is called the solar wind. Most of the time, it drifts past us unnoticed, but occasionally, it grows stronger, carrying energy across the vast quiet of space toward our planet. As these particles reach Earth, they meet something invisible but powerful, Earth's magnetic field. Like a gentle guide, the magnetic field pulls the particles toward the north and south poles, funneling them into wide, glowing rings around the planet. This is why the northern lights are usually seen in places closer to the Arctic, forming what scientists call the auroral oval, a soft halo of light circling the polar regions. As the particles drift downward, they enter Earth's upper atmosphere, more than 60 miles above the ground, far higher than airplanes ever fly. Here, they collide gently with gases like oxygen and nitrogen, waking them briefly from their stillness. And when these gases awaken, they glow. Oxygen, when touched at higher altitudes, releases a calm green light, the most common color of the aurora, soft and familiar. At even greater heights, oxygen can glow red, faint and rare, like embers cooling in the sky. Nitrogen adds blues and purples, subtle and cool, often appearing along the edges of the light. Together, these colors blend and drift, moving slowly as if the sky itself were breathing. Despite how vast and powerful this process is, it happens in complete silence. From the ground, the northern lights make no sound at all. They simply ripple and fade, unfolding their story without asking for attention, visible only in darkness, when the sky is clear and the night is deep enough to notice. This is why the northern lights are most often seen during the long winter nights near the poles, when the sun rests below the horizon and the stars have room to shine. In that darkness, the aurora becomes a quiet companion, never rushing, never repeating the same shape twice. As you rest now, imagine those slow waves of light drifting overhead. They have traveled millions of miles, guided by unseen forces, just to arrive softly in the night sky. And like sleep itself, they remind us that even in darkness, there is motion. Even in stillness, there is light. As the northern lights drift across the sky, they never follow a script. No two displays are ever the same. Each ripple, each curtain of light, is shaped by the changing mood of the sun and the quiet pull of Earth's magnetic field. Even scientists, with all their instruments, cannot predict the exact shape the aurora will take. It arrives differently every time, like a dream that can't be repeated. Long ago, before satellites and equations, people living beneath these glowing skies searched for meaning in the light. In parts of Scandinavia, the aurora was believed to be the spirits of ancestors moving across the heavens. Some indigenous Arctic cultures saw the lights as animals or souls playing in the sky, their movements full of intention and life. These stories were passed down softly, generation to generation, spoken during long winter nights much like this one. Though the aurora feels close when it fills the sky, it is actually impossibly far above you, stretching across hundreds of miles from east to west. A single display can be wider than entire countries, quietly connecting distant places under the same glow. People separated by mountains, oceans, or borders may be watching the very same lights, unaware they are sharing the moment. The aurora doesn't rush. It moves slowly, unfolding in waves and arcs because the charged particles are following invisible magnetic lines, tracing paths laid out long before humans ever looked up. Sometimes the lights appear as soft curtains. Other times, they form spirals, rays, or gentle pulses that brighten and fade like a steady heartbeat. Despite their calm appearance, the energy behind the northern lights is immense. During strong solar activity, enough energy flows into Earth's atmosphere to power entire cities, yet it arrives harmlessly, transformed into light instead of destruction. The aurora is energy made beautiful, danger softened into color. There are moments when the lights grow brighter, more active, responding to changes on the sun that happened days earlier. Massive bursts of solar energy, called solar storms, can intensify the aurora and push it farther south than usual. On rare nights, people far from the Arctic, who never expect to see such a thing, step outside and find the sky glowing softly above their rooftops. Still, the northern lights remain patient. They do not demand to be seen. Clouds may hide them. Cities may dim them with artificial light. And yet, above it all, they continue, quietly painting the upper atmosphere whether anyone is watching or not. As you breathe slowly now, imagine that vast, unseen world above you. A place where particles drift, fields curve gently through space, and light is born from motion. The aurora has all the time it needs. And so do you. The northern lights are not only shaped by the night, they are shaped by time itself. The sun, though it rises and sets each day, moves through much longer rhythms. About every 11 years, it completes a quiet cycle of activity. During the most active years, the sun releases more energy, more charged particles, and the aurora appears more often and more intensely. During calmer years, the lights grow shy, appearing less frequently, waiting patiently for the cycle to turn again. Because of this slow rhythm, there are years when the sky feels especially alive. Nights glow brighter, and the aurora dances more freely across the horizon. Then, gradually, the displays soften and become rare once more, reminding us that even light follows seasons of rest. On Earth, the northern lights also follow the rhythm of night and darkness. They are most often seen between late autumn and early spring, not because they happen more often then, but because the nights are longer. Darkness gives the aurora space to be noticed. Without it, even the brightest display would fade into daylight, unseen and unremembered. The best moments often come near midnight, when Earth turns just the right angle toward the stream of particles flowing from the sun. At that hour, the planet itself seems to pause, offering its polar skies fully to the light above. Time feels slower then, stretched thin and quiet. Even the moon plays a gentle role in the story. A bright, full moon can wash out faint auroras, while a darker sky allows subtle colors to emerge, soft greens, pale purples, and the faintest reds, barely there. In the deepest darkness, the aurora reveals its most delicate details, like brushstrokes painted in light. The lights also respond to the air below them. Clear, cold nights are often the best for viewing, not because the aurora needs the cold, but because still air and clear skies make the heavens easier to see. In that calm, the sky feels closer, as if you could almost reach up and touch the light. Yet even when hidden, the aurora continues. Above clouds, above storms, above the noise of the world, it glows quietly, tracing invisible paths across the planet's magnetic shield. As you rest now, imagine that slow, steady rhythm. The sun breathing out into space. The earth turning gently beneath you. The night opening wide enough for light to drift through. Nothing needs to hurry. The sky knows when to shine. For most of human history, the northern lights remained a mystery. They appeared without warning, shifted without pattern, and vanished as quietly as they arrived. People could only watch and wonder, knowing the sky was doing something important, even if its meaning stayed just out of reach. It wasn't until the 1600s that scientists began to study the aurora carefully. One of the first to give it a formal name was Galileo Galilei, who believed the lights were caused by sunlight reflecting off the atmosphere. He was mistaken, but his curiosity helped open the door to understanding. The aurora would teach humans, slowly, that even beautiful ideas need time to grow into truth. Centuries later, scientists discovered that the Earth itself plays a central role. The planet's magnetic field, generated deep within its molten core, acts like a protective shield. It deflects most solar particles away into space, protecting life below. The northern lights appear where that shield gently opens near the poles, allowing energy to slip through safely. As instruments improved, researchers learned to measure the aurora's height and movement. They found that the lights form high above weather, clouds, and storms, in a region called the thermosphere. Here, the air is incredibly thin, yet it glows brilliantly when energized, proving that even the faintest materials can shine when given the chance. The aurora also taught scientists something surprising: Earth is connected to space in constant conversation. Magnetic fields stretch far beyond the atmosphere, linking our planet to the sun in invisible lines. When the aurora brightens, it is a visible sign of that ongoing connection, a reminder that Earth is not isolated, but part of a larger, living system. Today, satellites orbit above the planet, watching the aurora from space. From this view, the lights form glowing rings around the poles, slowly shifting and breathing in response to solar energy. What looks like a single ribbon of light from the ground becomes a vast, luminous pattern when seen from above. Yet despite all this understanding, the northern lights have not lost their magic. Knowing how they form does not make them feel smaller. Instead, it adds another layer of wonder, proof that science and beauty can exist side by side. As you rest, imagine those invisible lines stretching quietly through space. The sun and earth in gentle conversation. Light appearing not as a spectacle, but as a soft response. Some mysteries are meant to be understood. Others are meant to be felt. As humans learn to understand the northern lights on Earth, a quiet question began to form. If our planet can glow in response to the sun, could others do the same? The answer, it turns out, is yes. Auroras are not unique to Earth. Other planets in our solar system create their own versions of glowing skies. Jupiter, with its powerful magnetic field, produces auroras far brighter and more energetic than anything seen on Earth. These lights can stretch endlessly around the planet's poles, glowing steadily rather than flickering, as if Jupiter itself is humming with light. Saturn also has auroras, soft and pale, shaped by both the solar wind and the planet's icy rings. Even Uranus and Neptune, distant and cold, produce faint auroral glows, responding quietly to the sun from the edges of the solar system. Wherever a planet has a magnetic field and an atmosphere, light finds a way to appear. Back on Earth, the northern lights have a twin. In the southern hemisphere, the same process creates the aurora australis, or southern lights. They mirror the northern aurora almost perfectly, appearing at the same time, shaped by the same solar energy, but glowing above Antarctica and the southern oceans instead. Sometimes, when solar activity is especially strong, both hemispheres glow together, two distant skies answering the same pulse from the sun. It's a reminder that the planet moves as one, even when its people are divided by vast distances. Auroras also leave their mark in subtle ways. They can affect radio signals, satellite systems, and even power grids during intense solar storms. Yet most of the time, they pass unnoticed by technology, revealing themselves only as quiet beauty in the night sky. Despite spanning planets and hemispheres, the aurora remains deeply personal. Each person who sees it experiences a private moment, standing beneath something ancient and vast, aware of how small and connected they are at the same time. As you rest now, imagine that light is not limited to one place. It appears wherever energy meets atmosphere. Wherever motion becomes color. Wherever the universe decides to whisper instead of shout. The northern lights are part of a much larger story. One that stretches far beyond Earth. And continues, softly, without end. When people watch the northern lights for the first time, they often expect them to behave like fireworks, sudden, bright, and dramatic. But the aurora prefers subtlety. Most of the time, it arrives slowly, spreading across the sky in soft arcs that seem to stretch and breathe. These arcs can change shape in moments. Curtains of light may fold and ripple, breaking into rays that appear to reach downward from the stars. Scientists call this movement coronal structure, created when the aurora aligns directly with Earth's magnetic field lines. To the eye below, it can look as though the sky itself is opening. Among the many colors of the aurora, green is the most familiar, but it is not the only one. On rare nights, deep crimson reds appear high above the Earth, glowing faintly like distant embers. These red auroras form at extreme altitudes, where oxygen releases light very slowly, giving the sky a softer, more mysterious tone. Sometimes, the aurora reveals unexpected colors. Pale pinks and gentle purples appear where nitrogen mixes with oxygen, often along the lower edges of the light. These shades are usually brief and delicate, visible only when the sky is very dark and the aurora especially active. There is a long-standing belief that the northern lights can be heard, that they crackle, whisper, or sigh as they move. While most auroras are completely silent, a small number of people have reported faint sounds during strong displays. Scientists are still studying this rare phenomenon, but if such sounds exist, they would occur very close to the ground, far below where the lights themselves glow. Whether silent or imagined, the idea of sound adds to the aurora's mystery. It reminds us that not everything about the night sky is fully understood, and perhaps that is part of its comfort. Some things are meant to remain just beyond explanation. As you relax now, imagine those slow-moving curtains of light. Their colors blending gently. Their shapes shifting without effort. A sky that moves not to entertain, but simply because it can. The northern lights ask nothing of you. They glow. They fade. And they leave behind a quiet sense of wonder, perfect for drifting deeper into rest. For as long as the northern lights have appeared, they have had quiet witnesses. Travelers crossing frozen landscapes would pause beneath them, their footsteps slowing as the sky began to glow. Early explorers in the Arctic wrote about the aurora in hushed tones, describing skies so alive with motion that they felt watched, as if the night itself were aware of them. Animals, too, live beneath these lights. Caribou, foxes, owls, and seals move through their world unaware of the spectacle above. The aurora does not disturb them. It produces no heat, no sound, no harm, only light far beyond their reach. Life on Earth continues peacefully beneath it, unchanged. Sailors once used the aurora as an unintentional guide. Strong auroral activity often appeared alongside disruptions in navigation, caused by magnetic disturbances. Compasses could drift slightly off course, reminding humans that invisible forces were at work above and below the sea. In some cultures, people believed the northern lights responded to human behavior. Whistling at the aurora was thought to call it closer. In others, people were warned to stay quiet and respectful beneath the glowing sky. Whether out of awe or caution, the result was the same: stillness, silence, and attention. Modern travelers often feel that same instinct. When the aurora appears, conversations soften. Movements slow. Phones are lowered. For a moment, people remember how to simply look up. The lights invite a kind of presence that feels rare and gentle. Even today, many people report the same feeling after seeing the northern lights, a sense of calm mixed with wonder. The realization that something vast and ancient exists beyond daily concerns, glowing patiently whether or not it is noticed. As you rest now, imagine yourself standing quietly beneath that sky. Cold air. Darkness stretching wide. Light moving slowly above you. Nothing asks for your attention. Nothing pulls you forward. The sky watches, but it does not judge. And in that quiet, it becomes easier to let go. For many who see the northern lights, the moment doesn't end when the sky grows dark again. The aurora has a way of staying with you, settling into memory like a half-remembered dream. Photographing the northern lights is not as simple as pointing a camera at the sky. The human eye often sees movement and color that cameras miss. Long exposures are needed to gather enough light, turning seconds into stillness. In these photographs, the aurora can appear brighter and more vivid than it felt in the moment, stretching time into a single image. Yet no photograph fully captures how it feels to watch the lights move. The slow unfolding, the way colors drift and change, these details live best in memory. Each person remembers the aurora differently, shaped by where they stood, who they were with, and how quiet the night felt. The aurora also has a way of altering our sense of scale. Standing beneath a sky filled with light, everyday worries can feel smaller, more distant. The mind softens, adjusting itself to something vast and patient. Many people describe a deep calm afterward, as though the sky has gently rearranged their thoughts. Scientists studying human responses to natural beauty have noticed that experiences like the aurora can reduce stress and encourage reflection. The brain responds to slow movement and soft light by relaxing, mirroring the same patterns that prepare us for sleep. In this way, the aurora becomes not just a sight, but a feeling. Even when unseen, the northern lights continue their quiet work. They shimmer above clouds, above oceans, above sleeping cities, leaving no trace except in the upper air. Their presence is constant, even if their visibility is not. As you rest now, imagine those lights moving above you, unseen but steady. A reminder that beauty does not need an audience. That light can exist simply to exist. Let your thoughts drift the same way. Slow. Gentle. Unattached. The night holds you, just as it holds the sky. Every so often, the northern lights grow brighter than usual. Not louder. Not faster. Just stronger. These moments are born from powerful activity on the sun. Sometimes, the sun releases vast clouds of charged particles all at once, known as coronal mass ejections. When one of these clouds drifts toward Earth and meets our magnetic field, the aurora can intensify dramatically, filling the sky with motion and color for hours. During these strong geomagnetic storms, the aurora can travel far beyond its usual home near the poles. Skies that rarely glow, over fields, deserts, and quiet towns, can suddenly light up. For many people, these rare nights become lifelong memories, unexpected gifts from the universe. Some of the most intense auroras in history were recorded centuries ago, long before electricity or modern technology. In the 1800s, one powerful storm made the sky glow so brightly that people believed dawn had arrived early. Newspapers could be read outdoors at night, illuminated only by the aurora overhead. These extreme events remind us that the sun and earth are deeply connected. When the aurora brightens, it is not just a visual display, it is Earth responding, adjusting, protecting itself. The magnetic field absorbs the energy, guiding it safely into the atmosphere instead of letting it reach the surface. Even so, strong auroras can leave subtle marks. Telegraph systems once failed during major storms, their wires humming with unexpected energy. Today, satellites may adjust their orientation, and power companies quietly prepare, proof that even gentle-looking light carries real strength. Yet the aurora never feels aggressive. No matter how intense it becomes, it moves with the same slow grace. Arcs stretch across the sky. Curtains ripple and fold. Brightness swells and fades like a long, steady breath. There are also rare shapes that appear only during powerful displays. Auroral spirals can twist overhead, and rapid pulses, called auroral substorms, can cause the sky to brighten suddenly before settling back into calm. These changes happen far above the earth, invisible in their cause, visible only in their beauty. Scientists continue to study these events, knowing that each storm teaches them more about space weather and the invisible forces surrounding our planet. The aurora becomes a natural signal, a glowing message written in light. But for those standing beneath it, none of that knowledge is required. What remains is the feeling. The sense that the sky is awake. That something vast is moving gently above you. That the universe is active, yet unhurried. As you rest now, imagine one of those quiet, powerful nights. The sky glowing slowly. The earth holding steady. Energy flowing, guided, transformed into color. Even strength, the aurora reminds us, can be soft. And with that thought, you can let your body sink deeper into stillness. Knowing the sky will continue its story, whether you are awake to see it or already dreaming. As the night deepens, the northern lights seem to slow even further. Not because they are fading, but because the world beneath them has grown quiet enough to notice their pace. The aurora does not appear all at once. Displays often begin as a faint, pale arc low on the horizon, easy to miss if you aren't watching carefully. Over time, that arc may rise higher, brightening gradually, as though the sky is deciding whether to speak or remain silent. These changes happen over minutes, sometimes hours. The aurora responds continuously to small shifts in Earth's magnetic field, adjusting its shape and brightness in real time. What you see is not a finished picture, but an ongoing process, light constantly being created, changed, and released. Even when the aurora looks still, it is never truly motionless. High-speed cameras reveal tiny ripples and waves moving through the light, far too subtle for the human eye. The sky is always in motion, even when it appears calm. There are nights when the aurora barely glows at all. These faint displays are often milky white or pale green, their colors too soft to fully register. Yet these quiet auroras are just as real as the bright ones, painting the upper atmosphere with light that whispers instead of sings. Over time, people who live beneath auroral skies learn patience. They learn that waiting is part of the experience. The aurora cannot be summoned, rushed, or controlled. It arrives when conditions align, teaching stillness simply by existing. This patience mirrors the rhythms of the natural world. Trees grow without urgency. Oceans move without haste. The aurora belongs to that same family of slow phenomena, reminding us that not everything needs to happen quickly to be meaningful. Scientists know that Earth's magnetic field itself slowly changes over centuries, drifting and reshaping the regions where auroras appear. Long after today's skies are forgotten, the lights will continue, slightly altered, gently shifting their paths across future nights. And far into the future, even when the sun itself changes, auroras may still glow on other worlds, under other skies, continuing the same quiet conversation between energy and atmosphere. As you rest now, imagine that long view of time. Centuries passing softly. Skies glowing, fading, and glowing again. Nothing is required of you in this moment. You don't need to stay awake. You don't need to remember every detail. Like the aurora, you can simply exist. Drifting. Responding. Resting. The sky will keep its slow watch. And you can let sleep arrive whenever it's ready.